So with that in mind, let's do some more examples. With this problem, we want to start, like the one before, by graphing these two lines. So let's start with the top one, 2x plus 3y is negative 6. And since we're in standard form, probably the quickest way to graph this is to find the intercepts. So when x is 0, you plug that in, this term goes away, you get 3y is negative 6, and dividing by 3, you get negative 2. And likewise, when you plug in y is 0, this term would go away, you get 2x is negative 6, divide each side by 2, and you get negative 3. So let's plot those at negative 3, 0, and at 0, minus 2. So we can draw a line between those, so something like that. And let's do the other equation. We have 3x minus 4y is negative 12. And again, let's just make a quick table, find those intercepts when x is 0 or when y is 0. So when x is 0, we get just this minus 4y is negative 12, divide by minus 4, and you get positive 3. When y is 0, that means that term goes away, you get 3x is negative 12, divide by 3, and you get minus 4. So we got minus 4 comma 0 and 0 comma 3, something like that. And let's connect those with our line here. And we can very clearly see that these two lines intersect somewhere around here. Now with these, we don't care about the exact value. We just care whether or not they intersect or not. And since they do intersect in one clear point, we know that A is the correct answer. There's exactly one solution. Now you could also take the other approach of solving these for y. So 3y is minus 2x minus 6. Divide everything by 3, you get y is minus 2x over 3 minus 2. And notice you have your slope-intercept form, and you can confirm that here that it is graphed correctly. At negative 2, and then essentially going in reverse, you go up to left 3, and you get to this point. So you could do it that way, and same with this one. You could solve it for y, and essentially compare their slopes. Because if the two lines have different slopes, they will always intersect each other. So let's keep going. We'll do another one. And again, we want to paste in our coordinate plane so that we can use that and we can actually graph these. But like I mentioned above, on the Khan Academy, it's an interactive grapher. So as long as you know 2 points, it'll connect the line and draw it perfectly. So let's look at this top equation here. We have 12x plus 9y is minus 36. Now, one thing you want to do, if you can, is see if you can reduce these numbers. Like, notice that each of these numbers here, the 12, the 9, and the 36, they're all divisible by 3. So let's just start by dividing everything by 3. So you get 4x plus 3y is minus 12. But notice that is the other equation. 4x plus 3y is minus 12. So it's the exact same line. We could graph it if we want, but honestly, in both cases, it's going to be the exact same line. You're going to have the same line on top of itself. So let's just graph it just for completeness. So putting in 0 here, 3y is negative 12, so you get negative 4. And putting in 0 here, 4x is negative 12, or x is negative 3. So you're at minus 3, 0, and 0, minus 4, something there. And we can connect those. But like I mentioned, we don't even have to draw the other line because it is the exact same line. We can kind of draw it like that just to show that they're on top of each other. And since it's the exact same line, that means they're going to intersect at every single point along those lines, meaning we have infinitely many solutions. But you could also notice if you solve it for y that they're going to have the same slope. The slope would be down 4, right 3 for each of those lines. So let's do another one. And again, we need our coordinate plane so we can graph these. And let's start with this top equation. We have 4x minus 6y is negative 24. And notice each of these are a multiple of 2. So let's divide everything by 2. And we get 2x minus 3y is negative 12. And for this other one, we get 2x, actually let me use a different color here, but we get 2x minus 3y is negative 6. So notice that The coefficients on x and y are the same in both of these, but they're not equal to the same number. So it's very similar to the one we did above, but now they're not reducing to the same line. So we know it's not going to be infinitely many solutions because they're not the same equation. And when the coefficients on x and y are the same thing, that's the case where you have the same slope. But since they're not equal to the same thing, it's not this infinitely many solutions where it's a line on top of each other. This is the case where we have no solutions. But to see that, let's draw a quick sketch of these. So we're going to use our intercept method since we're in standard form, and that's probably the quickest way to graph these. So plugging in 0 for x, minus 3y is negative 12, so divide by negative 3, and y would be 4. When you plug in 0 for y, we get 2x is negative 12, divide by 2, and x is negative 6. So at the point negative 6, 0, and 0, comma 4, we have our line. So and actually, this is the green line, so I should be careful with my colors here, but let's connect them after I fill these in with the green. So we can connect them with the line. Let's say it's going to look something like that. And let's draw this one now. So again, we're going to use our intercept method because it's in standard form. So we'll plug in x is 0, minus 3y is minus 6, divide by negative 3, and you get positive 2. Plug in 0 for y, 2x is negative 6, divide by 2, you get negative 3. So we go through the point, negative 3, comma 0, and 0, comma 2, something like that. And on the Khan Academy grapher, you'll see this perfectly, but for our case, it's going to be a slightly rough approximation, but you can generally see that these two lines are going to be parallel to each other. And the other way to confirm that to yourself is to just solve each of these for y. For instance, actually, let me stick with my colors here. If we solve this for y, we get minus 3y is minus 2x minus 6, divide by negative 3, so y is 2x over 3 plus 2. And for the green one, if we were to solve that one for y, you get minus 3y is minus 2x minus 12, divide by negative 3. Y would be 2x over 3 and plus 4. So it's the same slope in each of these, but they have different y-intercepts. So this is our case where they're parallel, they're never going to intersect, so we have no solutions.